Okay, last video in a series of the 5 videos. This is the second time recording it because the first time my storage was full and it stopped and I didn't realize it, so that was kind of a bummer. But we carry on. Just to say again, please, this is not your only study tool, okay? You should use your notes and study guide still. There will be stuff, especially in these last 2 videos, on the final that won't be in the last 2 videos, okay? Anyway, let's get started. So we talk about chemical compounds, and they all have formulas, right? So formulas, chemical formulas. So something like CaCl2, something we worked with a lot. It's called calcium chloride. And this is a chemical formula. So here we have the first one. The first element here is calcium. And the second one is chlorine. So we look capital C, capital C. So if it's a capital letter, it means the start of a new element. Lowercase does not mean new element. It means it's talking about the same old element. So we have calcium chloride here. So one thing I want to note is that this subscript, this is a 2. It's a subscript. It tells you how many of just the one before it there are. So it tells you there are 2 chlorines. It is not saying there are 2 calciums. There are just 2 chlorines, okay? I want to emphasize that. If there's no number, you can just assume there's one of them. So here we have 1 Ca, and we have 2 Cls, just like that, 2 Cls. But if you have like a 3 out here, so you have CaCl2 with a 3 out in front, so this is a coefficient. So the coefficient applies to both, every single element in the compound. This subscript still just applies to this one. So now I know there's 3 of them because of this 3. But how many Cl's are there? Well, there's 3 times 2 because the subscript, so there's 6 Cl's in this one. All right, so that is how we look through chemical formulas and understand how many elements and atoms are in it. I would encourage you to watch that again if you were confused because it's a very important point that you should know. Also, I want to talk about chemical reactions. So this is a big thing that we spend a lot of time on, chemical reactions. So the biggest thing with a chemical reaction that you should remember, so chem react is new products, okay? So chemical reaction means new products. It means you make a new thing. So if we have H2 and we have O2, so this is hydrogen gas and oxygen gas, that turns into, if we end up getting H2O out of it somehow. So the left side of this are reactants. So everything on the left side of the arrow is the reactant. And this product, it's a new compound, a new thing. So this is the product. Right? So one thing you can think is reactants turn into new products. But also we should note that the chemical reactions, we want their equations like this to be balanced. And what does balanced mean? So you think of a scale. It means you have the same amount of stuff on the left as you do on the right. So right now this is unbalanced. How do I know? Well, so there's two H's on the left here, and there's 2 H's here, so that's okay. But there are 2 O's, but only 1 O over here, so that's not good. So this is an unbalanced chemical reaction. So you don't need to know how to balance it. I'll do that for you, but you should know how to recognize just by counting if it's balanced. So you can put a 2 here and a 2 here. So then we have 1, 2, 3, 4 H's, and then 1, 2, 3, 4 H's here. 2 O's, and then 2 O's, so it's balanced. I will show this in another form also. So if these squares represent H's, so you have 4 here, and these triangles represent O's. You have 2 there. Right, so you should have, so on the left side you have 4 squares and 2 triangles. On the right side, you should end up with 4 squares and 2 triangles. So here, so if H2O, right, so it looks like this, and there's 2 of them. It's 2 H2O because of this. So if we count 1, 2, 3, 4 H's here, 1, 2, 3, 4 H's here, 2 O's here, 2 O's here. So the number on each side is the same total. So that means the number of atoms is conserved, which also means, because atoms have mass, the amount of mass is conserved. So this also pertains to the law of conservation of mass, which tells us that mass is conserved. Think of the experiment investigation you planned with the balloon, baking soda vinegar, and the flask. Okay, the only other thing I want to talk about in this video is valence electrons. So we kind of talked about that in the previous one. But right, if you have your periodic table here and there are different groups, the whole point is every element wants to be like group 8. So 8, or sorry, these are the noble gases, group 18. But they want 8 valence electrons. So 8 is great, is the point, right? 8 is great. So remember we had our atom from the previous video, and we have here 2 in this one, and then this outer level has 3 electrons, but it wants 8. So there are 5 spots where it wants electrons, right? So they want electrons. They want to get to 8. And the way they get to 8 is through bonding. So NaCl, right? This is table salt, sodium chloride. So if we look at Na here, it's in group 1. So it has 1 electron in the outer shell. Cl has 7. 1 plus 7 equals 8. So they work well together because they want to get to 8, just like that. You should review your notes for more stuff on that. Last thing I want to say for chemical reactions is just you should think about endothermic, which is absorbing heat so it feels cold, exothermic, where it releases energy so it feels hot, things like gas production. So all that stuff you should look over. But otherwise, good luck.